In this video, I will show you how to optimize your game. So first thing is using process. This is very not efficient because each element that has process function, this is not really efficient because it will run every single frame on every single object that has this function. So instead of this, you can either put it in function underscore input, and here have this thing. Since we need the player to press the left mouse button, and other variables are checked with other functions, other signals. So here, if we start the game, press it, here, press it, you can see that it works the same way, but this runs not every single frame, but anytime the player presses any button or uses the mouse. Now let's say we have a lot of inspectable items. They're gonna stack up in one place. It doesn't really matter to us. Now we have 9 items that are running the input function every single time we press something, which is again not as efficient as it can be. So what we're gonna do is go into our inspectable item. On the right, we can see node, and here we see signals and groups. We're gonna go to groups, manage groups, and here we're gonna add a new group called left mouse. Let's say like that, add it, and we're gonna add it to our parent, which is inspectable item. So add it, press OK, and we can see that we have a group attached to our inspectable item, left underscore mouse. So now what this is gonna do is help us emit a signal every time a player presses the left button. So now what's gonna happen is we're gonna go to main, and here I have made a game manager script which is on our root node, and here we're gonna add a new function which will be the same one, input. And here, if we press the left mouse button, then what we're gonna do is get underscore tree, call group. Here we have our group, left underscore mouse. And in the second, we have to call a method. So it's gonna be check, let's see. Now we don't have any arguments, so we don't need to press anything here. We're gonna leave it just like that. Go back to our inspectable item. We're gonna copy our if statement, delete the entire event function, and here we're gonna put a new function called check. And here we're not gonna add anything into the parentheses because we do not have any arguments. Now I copied and pasted our if statement, but here I'm gonna remove the if left mouse button is, and here we're gonna just check if player is inside the collider, and here is mouse inside the other collider. Now I have divided the inspectable items so we can see clearly, and here let's say I'm in this, we press inspected on just one. Now here inspected because I'm in both. So this is more efficient because we call the input only on one and then we get the items. So what this does is basically, instead of calling on every single input we do, we just call on single game manager object, and then if it's mouse click, then we check for inspectable items if the player is inside and if mouse is inside. This is really efficient, and I recommend it doing it. Now let's say that we want any textures, scenes, objects, or anything else. So what you're gonna do is create a new variable, let's say book, preload. Here we're gonna reference our book texture, and in the ready function we're gonna do texture equals book. It should work. So if we start, yeah, we can see that it spawns with the book texture. It works fine. So why is this good? Instead of loading and preloading, basically before the game is even initialized, the script already has the book texture prepared for us to use, and we save on resources as well as the player experience. Another thing you can use is onReady. The same as for loading textures or scenes, we can use this to reference different child nodes or anything else as shown here. Instead of using like copy this and then we go here and we paste here, this certainly isn't efficient, and instead we use onReady. And another really great thing you can use is, let's create a new script, call it global variables, delete everything, and let's say we want to have an enum with states, and here we're gonna have idle, we're gonna have moving, we're gonna have jumping, we're gonna have crouching, and we're gonna create a new variable, let's say status. It's gonna be a type of state, and it's gonna be a state dot, let's say, jumping. So what this does is basically creates a variable which is a state of one of these states. So now it is a state of jumping. Now let's say that we need the state to be referenced in a lot of different files. So instead of those files referencing character body and trying to get the variable here, it's way more efficient to go into project settings, go into autoload, and here we're gonna paste our global variables and add the node right here. You can see it's enabled. Close this, and now we can set it, we can get it, and basically if we go, for example, into inspectable item, and we really need to know the current character state. So what we do here is, for example, print, and here it's going to be global. You can see var. So instead of underscore, it makes the next character a capital letter. So it's going to be global var and then dot, and it's going to be status right here. So if we do this and go into the game, we can see that it prints 2. So because this is in the inspectable item, it prints on every single inspectable item. So why does it say 2? Well, enums work like this: 0, 1, 2. So because it's jumping, it is the second value. It doesn't print the state. Now let's say we want to change the value. So we go into our character body. Here we're gonna have a function of ready. And now let's say we want to change the value the player is currently in. So we go into, let's say, ready function, and here we call our global variable. It's gonna be a status, and we set it to global var dot state and dot we select what we want. So we can see all the options: idle, moving, jumping, crashing. So let's see, we want it to be idle now. Save. And boom, it's 0. Note one thing: I put this in ready and I put this in ready. So if you try this and it doesn't work, it's because this is called after we print out the value, which is possible. We can even test it out. So we're gonna put, we can see that for now it for us it worked. So I'm gonna put this print here, delete this, and go into here and replace this with this. So it should print 2 even though we change it to 0. Yeah, you can see 2. That's because we changed the value after printing it. So this is pretty much it. I hope you enjoyed this video. I hope it was helpful, and goodbye.